Today we will be learning about topics that are associated with stoichiometry. Particularly, we're going to look at molar ratios and how to convert between moles of a substance to grams of a substance. So the first thing we would want to address is making sure that we understand what a mole is. A mole is going to be a standard unit of something that we're measuring. In this case, we're looking at atoms, molecules, and very small particles. So in the way that saying that it's a standard number is kind of like saying the way that we talk about a dozen. A dozen is a term that means a specific number of a substance. It can be any substance we want it to be. We can have a dozen roses, a dozen eggs, a dozen donuts. All of those mean we have 12 of something. So the value of a dozen is 12, and the value of a mole is 6.02 times 10 to the 23rd. This is what we call Avogadro's number, and obviously it's a fairly large number, but it just means we have that many of whatever we're talking about. So now when we have a mole of a substance, not all of them are going to weigh the same thing. And so we look at the mass of a mole of something to look at how much does that certain number of objects weigh. So for example, if we were looking at tennis balls and we were talking about having a dozen of something, a dozen tennis balls and a dozen bowling balls clearly do not have the same mass. And the same is true when we look at elements. If we look at a mole of hydrogen and compare it to a mole of zinc, they will not have the same mass. And so that's why we have to be able to convert sometimes between moles to masses, from moles to grams. So when we talk about that, we can look at where we find molar mass. So if we were talking about an element, we would look at that at the periodic table and find the number at the bottom. And that atomic weight is equal to 1 mole of a substance. So in this case, we're looking at carbon. So 1 mole of carbon would be equal to 12.01 grams of carbon. The same applies for looking at molecules. So this time we have to do one extra step though, and we're going to have to add the atomic weights together. So for example, if we wanted to figure out how much 1 mole of ethane, which is C2H6, then we would look again to the periodic table. We would find those elements on the periodic table. C for carbon has a mass of 12.01, just like we did before. But this time, since we look at the formula, we see that there are 2 carbons. And so because there are 2 carbons, we're going to multiply by 2. Then we're going to look at hydrogen. Hydrogen has a mass of 1.01. And if we look at our formula for the compound, we have 6 hydrogens. So I'm going to take the mass and multiply it by 6. Then what we're going to do is we're going to add those 2 quantities together. So in this case, the mass of 1 mole of C2H6, otherwise known as ethane, is going to be 30.08 grams. So that's how we can compare different masses. It's kind of like the carbon might be like our tennis balls and the ethane might be like our bowling balls. There's the same number of them, 1 mole of them, but they have different masses. So to make another analogy for you, if we have 10 dimes and $1, those are equal to each other. Because they are equal to each other, we can make them into a fraction. 10 dimes divided by $1 still is equal to 1 because those quantities are equal to each other. We could also write it the opposite way, with $1 over 10 dimes. Still is equal to 1. So depending on what our needs are will depend on which one we put at the top. We'll talk a little bit more about that in the next few slides. Now, again, we'll compare that to moles. If I look at the thing we just used in the last slide, 1 mole of carbon, we said weighs 12.01 grams. And so we can now set those into ratios as well. And again, either one can be on top depending on what we're going to use because those values are equal to each other and they would cancel out. So now the big question of how do we get from moles to grams? So if you're given moles, we're going to use the ratio that puts grams on top. So if we were told to convert 0.8 moles of carbon into grams, we would start with what we're given, which was the 0.8 moles, and then we're going to multiply by that ratio. And in this case, we're going to put the grams on top because that's what we're looking for. The reason we put moles on the bottom is because we have moles on top here and moles on bottom here. Those quantities are going to cancel out, and that will leave us in the unit that we're looking for, which in this case is grams of carbon. At that point, you can just deal with your numbers. So we'll take this one here, 0.8, and we'll multiply by 12.01. and then we'll divide by anything that's on the bottom, which in this case is 1. Anything divided by 1 is itself, and so after doing a little bit of calculator work, you can say that 0.8 moles of carbon weigh 9.6 grams. So we can do the same process for ethane. So again, we'll take the same number of moles, but we're going to find out that they weigh different things. So we start out with what we're given, and again do the conversion factor. Think through in your head which one goes on top. What we're looking for goes on top, what we're getting rid of goes on bottom. So we're looking for grams and we're getting rid of moles. So we look from the things that we just did on the previous slide where we calculated the mass of ethane. So we had the mass of ethane was 30.08. And so we put those on top. Again, our moles will cancel and leave us in the unit we're looking for, which is grams. So we'll do 0.8 times 30.08 divided by 1, and that gives us an answer of 24.1 grams. So that's how we convert from moles into grams. If we wanted to do the opposite, if we want to go from grams to moles, we do similar, but the only thing we do different is we're going to flip that ratio. So, as I said, putting them where the moles are on top, grams are on the bottom. So this time we're going to convert 68 grams of carbon into moles. So we start with our given and then use the ratio. Remember that since we're looking for moles, they're going to go on top and grams are going to go on bottom so that we can cancel them out. It's the same ratio that we used from finding out how much it weighed earlier. This time, instead of having the 12.01 on top, we have it on bottom. So we have 68 times 1, which is still 68, and then we're going to divide by 12.01. Grams are canceled, and that gives us our answer of 5.7 moles of carbon. So in 68 grams, we end up with 5.7 moles. All right, so we'll do one more example. We'll do one with the ethane. So we'll use the same amount of grams. So you might want to think in your head, since ethane weighs a little more, would we end up with more or less of the moles when we finish? So think about that for a moment, and we're going to check our answer in just a moment to see what happens. So we have 68 grams, and so we start with our given. Again, we're going to multiply by that ratio. Remember that moles will go on top, grams will go on bottom. The number that we got was from earlier when we calculated the mass of ethane. So again, we're going to do the tops together. 68 times 1 is still 68, and then divided by 30.08. And also our units for grams have also canceled. So when we punch that in the calculator, we end up with 2.3 moles of ethane. Hopefully that matches what you were thinking would happen. So to summarize, in this lesson we looked at converting between grams to moles and moles to grams, and looking at what moles are. In our next video, we're going to look at how to convert between moles of one substance to moles of a different substance. So we'll see you next time.